Hey guys, I wanted to give you a little hint here on how to approach the Jumpers Lab if you're having trouble figuring out the math. So I do want you to try to figure it out on your own first, and this will kind of point you in the way. I'm not going to tell you the answer, but I'm going to try to give you strategies that may help you in analyzing the data from the Jumpers Lab. Okay, so you have a whole bunch of data here about how much things weigh and how high they're able to jump. And a good way to amass all of that data is to make a graph of it and see if you can find any patterns in the graph. And if you do, there may be ways you could manipulate the data to make it easier to make predictions. Okay, so let's start off with the graph here like this here. So suppose we have this data set, X versus Y. And when, let's make X 1/2 and Y will be 1.5. And X is 1, Y is 3, X is 2, Y is 6, X is 3, Y is 9, X is 4, Y is 16, 5, 10, 15. So it'd be up about here. Okay. And when we do this, we find that we get a straight line. I forgot to bring along a straight edge, so we'll just do it this way, but this is fine. All right, and when we do this, we find that we get a nice straight line from the plot. It's a linear plot. I kind of missed this one here because I looked at it wrong here. So let's see. Oh, not 16, it should be 12. Okay, 5, 10, 12 should be here. Sorry about that. Okay. So when we plot this data, we get a nice straight line. Now, a straight line is easy to handle when we have a data set like this. Because if you want to know, for example, what is Y when X is 2.5, you can just say 1, 2.5, look up here, read it off the graph, and say, hey, it's 5. Or it's 7.5, 7.5. Is that point. So since it's a straight line, it's easy to figure out where a point is that's in the middle of the data set. And likewise, if we want to know what Y is when X is, say, 6, well, that's going to be 18, and that'll be up here someplace. Let's see, 6 would be, we just project the straight line farther on up. Past the end of our data point. And since it's a straight line, it's easy for us to figure out, to project the data and figure out what the value is, okay? So for a straight line, it's easy to figure out a point that's in the middle of the data, and it's easy to figure out a point that's off the end of the data set. It gets more complicated, or it gets more challenging if you have a data set which is curved. So for this one here, we've got X versus Y. If X is 1/2, we're going to say that Y is 1/4, which is very close in here. When X is 1, Y is 1. When X is 2, Y is 4. When X is 3, Y is 9. When X is 4, Y is 16. And what we wind up with is a curve. Okay? We wind up with a curved data set. I need to move this so you can see it a little bit. There we go. All right, now curves are a little harder to handle. They're not so bad for a point which is inside the data set, because you say, okay, we want to know what Y is when X is this, and we can just go up here and we can read it off the graph. We could be fairly close because we have values on either side, which will tell us approximately what the curve is in between. But if we go off the end of the data set, it's difficult to tell. We know it's curved and we know it's going to keep on curving, but it's difficult to tell if you're, when you project this, if you're making the right curve. I made such a steep one here, it's not really the best example, but what if our data set went something like this? And then, well, we want to project our data off the end, but it's difficult to tell what is the proper curve. It's easy to tell where a straight line goes. It's not easy to tell where a curved line goes. Okay, so one way to handle this, and again, we're looking at this this graph here that I made for the initial example. If you recognize, hey, this looks like a parabola. It looks like this may be some sort of a squared function. So If you suspect that that's the case, if you know the mathematical equation which produces that shape, you can manipulate the data and try to turn it into a straight line. Okay, so for example, we could create another column of z. And since we think that y is equal to x squared, we can say, well, what happens if we take z is equal to the square root of y? All right, and we just take these numbers, take the square. So the square root of 1/4 is 1/2, because 1/2 times 1/2 is 1/4. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. And now if we graph x versus z, then we get 1 and 1, 1/2 and 1/2, 2 and 2, 3 and 3, 4 and 4. And now we have a straight line again. By manipulating our data, we've found a way to make it into a straight line. And now we're in good shape because it's easy to project a straight line. And if we want to know a data point that's way out here, well, that's pretty easy to find because we can just project our straight line past the end of our data. This is the end of our data right here, but if it's a straight line, we can project it and we can be pretty sure what this value is out here. And once we have a number for z, now we can just undo this and take it squared. So if this turned out to be 7, okay, then we'd say 7 squared equals 49. And now we know the value of the variables. When x is 7, y will be 49. Okay. So the point is you try to figure out the pattern of the shape that you have that you've graphed, and then mathematically change it to turn it into a straight line. We could also have, instead of taking the square root of y on this, we could take x squared. And x squared would be 1/4, 1/2 squared is 1/4, 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. And again, we'd have a linear graph because the horizontal and vertical values would be the same. Okay, now the graph that you are working with today, that you're creating today, probably looks something like this. Okay, when x is 1/2, y is, let's go with this one. Let's go with, let's see, so we're going to call this 1. So yeah, let's go this one, 1/2 and 2. So we're going to call this 1, 2, 1, and 2. When x is 1, y is 1. Actually, that goes right here. When x is 2, y is 1/2. And when x is 3, actually that goes right there. When x is, actually it goes here, sorry, my bad. And 1, 2, 3, 4. When x is 3, y is 1/3, which is about here. Okay, and we wind up with a curve that looks like this. All right. Now you may recognize this as looking like an inverse relationship where y is equal to 1/x. There are other curves that create this as well, but the point is you want to try to find an equation which approximates your line and then do a mathematical trick like we did down here so that you transform y into a z number so that when you plot it, it will make something like a straight line. And when you make your straight line, then it's easy to find a data point which is off the end of the data set. Okay, that was kind of a quick and dirty one-take thing. I hope it was helpful to you. Yeah, good luck with this one, and we'll see how y'all do. All right, thanks for your time.